Okay, this is a review of a functional signal generator called the Victor VC2002. It's one of many pieces of test equipment which is coming out of China these days. We'll take a look at the product, see if it meets its specs, and then we'll do a teardown and see what's inside.
So fairly standard for any sort of function generator. You've got the BNC output here. There's a frequency adjust knob here which you can use to make the waveform come up and down. As you can see, it takes quite a few turns to change the frequency. It's a multi-turn pot, so you can get some pretty accurate frequencies out of it. Down here an amplitude adjustment, and up here a delay adjustment, which bears a little more discussion in a moment. A couple buttons here for attenuation, so if you want signals which are not in the volts but millivolts, you can put those in. You can change between a sine wave and a square wave and a triangle wave. Somewhat unusual is a range button here, which runs in different ranges. So you have 7 different ranges on the product that can go between 0 Hz and 2 MHz. A run button and a reset button. The only other things to notice is a frequency display here and an amplitude display here. And this is the delay button. On a square wave, it makes a lot of sense. You can see it adjusts the duty cycle. On the triangle wave and the sine wave, it's a little more unconventional.
Okay, so what we have now is it's running at its maximum capabilities. It's on a sine wave here. We'll just switch it into square wave mode, and when you take a look at the square wave, you can see it's fairly distorted, and this really suggests that this product has a fairly weak output driver stage, which has fairly limited bandwidth, and it's really struggling to get nice sharp transitions. Okay, so we got it in its maximum rate here. This one runs about 2.25 MHz. And we'll zoom in the waveform here. And one thing you really notice quite quickly is there's pretty significant distortion in the waveform. We'll just zoom in here. This is really actually a result of the chipset they've chosen, and we'll get into that in a minute here, but it's something that you should be aware of, especially if you're planning to use this thing for audio work.
So pretty straightforward case construction. It's just got some mounting screws in the back here. We can get a screwdriver in, hopefully take them off, and take a peek inside the product. Okay, got the screws off the product, pretty easy to get into. Let's take a peek at what we got here. Looks like there's a bit of shielding on the top, that's nice. So it looks like 2 main boards. They got a display board here and a controller board here. Controller board looks pretty straightforward. Looks like it's got an Atmel processor on it. It's got some linear chips. This one's from Maxim. Goes out into the coaxial output. Looks like the power system's on the same board, an AC input, DC power conversion system, and a microprocessor, so that's fairly straightforward.
Okay, so here's just a straight down picture of the main control circuit board. If you poke around a little bit, you can find the heart of this instrument. It's a chip here that's in the red box. It's a Maxim MAX038. A really important metric in any signal generator is the purity of its output waveforms, and if you open up the manual, you can quickly find the figure for this one. This one's showing a 2% distortion on the sine wave, and that might sound quite good until you actually open up a really high-end product from Agilent. You can see that you can get signal generators down to 0.02% distortion quite easily. What this really means is if you're interested in using this unit for audio fidelity work, it's perhaps not the best choice because the distortion is fairly high. For general lab use, digital use, it's not bad at all though. In terms of build quality, you can see a couple things which cause a bit of concern. The material there around the solder pads is a leftover flux. They didn't bother cleaning it off. And then you can even see little solder splashes, and those are a little concerning because those things will eventually break off from the resist and potentially short out your instrument. That's not so great. On the lid, there is a good, nice shielding on the lid, but when you take a real close look at it, you see that these old whack and stack of washers to get the screw to mate. Tells me they're industrial design. This one a little weak. In terms of price and whether this is good value, if you look at the internet on eBay, it's pretty easy to get one of these imported from China or Hong Kong for $99, about $25 shipping into Canada or the US. If you sort of consider the price there, consider its 0 to 2 megahertz operation capabilities, take into consideration build quality, waveform spectral purity, this is an average buy. It's clearly not a high-end function signal generator.